Welcome to this video demonstration on the integration between QlikView and QlikView Expressor. My name is Michael Torello. I'm with the Global Product Marketing Team at QlikTech. In this video, I will review some of the terminology used throughout the presentation that will better prepare those who may not be familiar with its content. I'll then cover the current QlikView integration components found in the current version of QlikView Expressor, and finally provide a demonstration of this integration. Below will appear some basic definitions of the terminology I will be using. It will better prepare you for the content that is to be demonstrated in this video. The first term is operators. Operators are the icon-like shapes used when building Expressor data flows. They consist of read, write, transform, and many others. You connect them to other operators to control the flow of data, hence the term data flow. The next two terms are schema and semantic type. A schema is used within read and write operators. It defines the physical external record structure of tables, files, and other data sources that will be mapped to a logical internal semantic type. A semantic type simply defines the logical internal metadata or meaning to the Expressor data flow. It is composed of an artifact known as a composite type. A composite type is an artifact of a semantic type defined within schemas. They can be local to an operator or shared with others. It contains a collection of field attributes that represent the Expressor internal record structure. It provides attribute naming, data type selection, constraint rules, error handling, and corrective actions. Now we'll cover some brief QlikView terminology. The following are a list of QlikView files or streams. The first one is QVW. This is the actual QlikView application mashup that you view and interact with. It contains all visual widgets, load scripts, field metadata, and embeds a recent snapshot of the data. Expressor can harvest metadata from this file to create an Expressor QlikView schema. The next one is QVX. This is QlikView's open and publicly available data exchange format, which contains uncompressed data and metadata. This is what Expressor can currently read as a data source with its QlikView read operator, and writes as a target with the QlikView write operator. This file can also be used to harvest field metadata from. The last one is QVD. This is QlikView's proprietary compressed data stream or file. It too contains elements that describe data that can also be extracted to create QlikView schemas. Next, I'll describe the current integration with QlikView as of the recording of this video. The first one being the ability to create an Expressor QlikView schema from QlikView's QVX, QVW, and QVD files. This allows us to harvest existing QlikView field metadata to be used with the QlikView read and write operators. You will see an example of this during the demonstration. Read QlikView operator simply reads QlikView QVX files to be used as a source of data within an Expressor data flow. And lastly, write QlikView. This creates a QVX data file defined by the QlikView schema. The file will contain all the data elements and table descriptors from the final downstream operator. The demonstration use case I prepared will focus on the value of Expressor's QlikView integration by demonstrating how you can leverage existing work that has already been created with QlikView. Using a previously prepared Salesforce QVW template that I downloaded from the Qlik community website, I will use Expressor to extract its field metadata and create a QlikView schema. I will then create an Expressor data flow using Salesforce read operators to pull records from the case, account, and contact Salesforce objects. I will merge them together and enrich, cleanse, and calculate new fields using the transform operator. I will write the final records to a QlikView file using the QlikView write operator. Now, in order to do this properly, I will need to map the QlikView schema to the Expressor metadata semantic type. Now that we have a properly constructed QVX data file, we can modify the load script of the existing QVW QlikView application and feed the visualizations from it. From the Expressor Design Studio interface, I verify my connection artifact that it points to the location where my QVW, QVX, or QVD files are. In this case, it's in the Z drive under QlikView Cases. I expand my schema folder, and I create a new QlikView schema. Select my connection artifact, and choose which extension that I want to extract the table metadata from, in this case QVW. Here it will explore all of the tables that are inside the Salesforce Quick Start template that I downloaded from the Qlik community. The example that we're going to reverse engineer today is the case table. So I will select case. Finally, I will name my schema. This will create a schema object or artifact available under the schemas folder. If I open it up, you will notice the representation of the physical external structure of the QVW file for the case table. On the right-hand side is the semantic type, the internal logical representation. Within the Design Studio interface, we have the option of choosing operators that perform different actions on data. I have pre-configured templates that access Salesforce information, as well as pre-configured templates that transform and merge data. I will create the data flow by dragging the Read Salesforce for Account, Read Salesforce for Case, and Read Salesforce for Contact. I will then use my join operations, which already have the pre-configured keys, to join the contact and the account information, as well as to join case information to the contact and account info. Then we have transform operators, and transform operators allow you to compute, cleanse, calculate, look up. They do a variety of different functions on data. And if I open up the transform operator, you can see the rule within the operator simply calls a decode function. There's a variety of rules that can be applied. In this case, these rules can be named and made available and exposed within our metadata. You will also see all of the fields that auto-propagate over with the blue arrows, including the diamond shapes, which are the new derived fields based off of the rule. I use another transform operator and then derive some new fields. Now this would be similar to writing an expression within the QlikView script. If I was to edit the script and navigate to the cases, which is the one that we're working with today, you'll notice in the load script it has functions to pull out date, year, month. It does some concatenation as well. What we need to do next is expose all of the metadata that is available here in the Outputs panel and make it available to the QlikView schema. And we do that by creating a composite type. I can make this available by selecting Share Local Composite Type and giving it a name. And you'll see it pops up underneath the Types window on the left in the Explorer bar. We next can apply that type to the schema we created a moment ago. We do so by selecting Assign Shared, and this will bring up the list of shared composite types that have been created. By selecting that composite type, it will ask you if you want to auto-map any of the matching names. I'll say yes, but in this case I don't have any matching names, so there isn't any auto-mapping done. So I'll have to map them manually. We will now assemble our data flow with the right QlikView operator. We will configure it with the appropriate connection artifact, the schema we created, the type associated with that schema. We will call it sf_case.qvx, the name of the data file to be written. And if I click Use Default Values, it will pull out the table name that was extracted from the QVW. In this case, the name of that table was case. Okay, we're ready to run. By clicking Start within the Build menu, this will now reach out to Salesforce.com, pull out the appropriate information from those objects, merge them together, execute a few transformations on them, and now write out the QVX file. If we navigate to my Windows Explorer and we do a search on date modified, you can see that the sf_case.qvx file was created at the appropriate time. In this case, it's 3:44 p.m. Now we'll switch over to the QlikView application, and this is the copy of the one that I downloaded from Qlik Community. Here's the original one with the snapshot of data. I basically just cleaned up the tabs and cleaned up the scripts for the demonstration, and you can see that there hasn't been any data loaded. If I go into Edit Script, here is the original script that came with the QlikView application. I'm going to delete that out and pull in a load script that I have available within my notepad. And we'll paste that right in here. And what you'll notice is my load attribute names represent the names that were in the QVX file, and the from is the location of the QVX file, the new one that we just loaded. So what we're going to do here is save this and then do a reload. And you will see now that the existing application has been populated with data from the QVX file created by the Expressor data flow. In summary, I extracted field metadata from an existing QlikView application to create a QlikView schema. I then created an Expressor data flow to read, merge, and enrich incoming Salesforce data. We then produced an Expressor internal semantic type to be mapped to the QlikView schema. Finally, we wrote out a new QlikView QVX file based off of that schema. This QVX file can then be used in a new or existing QlikView application.